Have you ever watched a moving crew wheel out a whole couch and wondered, could I pack this smarter? Imagine moving the same home two ways, once with neat-labeled boxes and once moving entire furnished rooms. Both get your stuff to the new place, but the effort, speed, and cost feel completely different. Which one sounds like modern cloud computing? It's both, and that's exactly what we're unpacking. Picture this. It's moving day. You're standing in your apartment surrounded by things, plants, a stack of books, your prized blender, and that living room couch that's somehow become a part of the wall. You have two options. Option A, you pack the blender, books, and a few cushions into labeled boxes. Tuck fragile things in bubble wrap and stack the boxes onto a truck. Option B, you call the movers who pick up whole furnished rooms, couch, rug, lamp, and wall art still in place, and carry the entire room over. Both options move your stuff, but they're very different experiences. That real-world decision is the heart of containers versus virtual machines. Let's map the analogy so it's crystal clear. A container is like that set of labeled boxes. You pack only the items you need, label them, and they're ready to go. A virtual machine, or VM, is like packing an entire furnished room. The VM includes not just your items, but the furniture, the cabinets, even the wallpaper and the lights. Everything that makes the room function on its own. Now let's take a breath and unpack what that means for apps. In plain words, a virtual machine copies an entire computer inside another computer. It includes its own operating system. That's the whole room. So the VM can run independently. You can move that whole room to almost any building that has the right kind of truck and space. It's reliable and isolated, but heavy. A container, on the other hand, takes only the things the app needs to work. The app files, the libraries it uses, and some settings, all packed neatly in a box. Containers share certain things from the building they're placed in, like the plumbing and electricity. In computer terms, containers share the host computer's operating system core, so they don't need a full copy of the OS inside each box. That makes them light, fast, and easy to move in large numbers. Let's translate a few common terms into moving day language so they're not scary. An image is like a packing list and a set of instructions for a box. It tells you what goes inside and how it should be labeled. A container runtime, think Docker, but the name doesn't matter, is the tape, labels, and dolly that let you build and move those boxes. A hypervisor, the software that runs VMs, is the moving crew that lifts whole rooms intact and carries them over. And orchestration systems, like Kubernetes if you've heard the name, are the moving day manager, who coordinates dozens or hundreds of boxes and rooms, so nothing is left behind. Why do people prefer boxes, containers, for so many jobs? First, speed. Because boxes are lighter, they're quicker to pack and unpack. A container can start in a second or two, because it doesn't need to boot an entire OS. You just open the box and the app runs. A VM can take minutes, because you're waiting for the whole room to be set up and its systems turned on. Second, density. Imagine stacking boxes in a storage locker versus arranging whole rooms. You can fit many more boxes in the same space. On a real server, that means you can run many more containers than VMs, because each container shares the host's operating system parts instead of carrying its own. Third, consistency. If you label boxes and follow the same packing list, the contents will be the same wherever you unpack them. That's why developers love containers. A container that runs on your laptop runs the same way on a colleague's machine or in a cloud data center, because everything the app needs is in the box. But like the real moving world, there are trade-offs. When you move whole rooms, you get stronger separation. If something spills in one room, it's less likely to affect another room. VMs offer stronger isolation because each VM has its own operating system, its own walls and sockets. Containers share the same floor and wiring. A misbehaving app in one container can sometimes make life harder for others if the shared parts aren't carefully managed. Another trade-off is compatibility. If your old coffee machine only works with a certain electrical box, you might have to move the whole room to be sure it works. Similarly, some software needs a specific operating system to run. If that's the case, a VM that includes that OS is the safer choice. With containers, you're relying on the host OS to be compatible with what's inside the box. Now, 2 everyday examples to make this stick. Example 1. The local bakery's website. The bakery wants to run a small order form so customers can place cake orders online. The team packs the order app, its small database client, and a few tweakable settings into a container. It's like packing a set of recipe books and the cash register in a box. When the bakery moves hosting providers, the entire box moves with no surprises. The site launches in seconds, and the team can run several instances of that box during a busy morning. Example 2. The accounting department's legacy payroll system. This system only runs on a specific older operating system and depends on a set of utilities that are tricky to replicate. Instead of wrestling with those compatibility issues, the IT team moves the whole office, a VM that includes the exact OS and utilities. It's heavier and takes more time, but it guarantees the payroll system behaves exactly the same after the move. You can also mix both approaches. Imagine you're moving a household where most rooms can be packed into boxes, but a priceless antique piano must be transported intact. You'll use boxes for the plates and books, and a room move for the piano. In cloud work, teams often run most services as containers, but keep a few legacy or particularly sensitive services in VMs. A quick note on security, because it matters. Boxes that share the building's wiring need good locks on the doors of the boxes and a careful building manager. Containers need good guardrails and monitoring, so one noisy or compromised container doesn't disrupt others. VMs have thicker walls by default, but they are not invincible. Good housekeeping, clear access rules, and updates are important either way. By now, you've seen the bright spots and blind spots on both sides of the truck. Containers are agile, efficient, and portable. Like labeled boxes you can stack high and move fast. Virtual machines are sturdy, self-contained rooms you can pick up and place elsewhere. Great when you need a complete environment that won't rely on the building. Let's recap using our moving day picture. If you want speed, density, and predictability when you move many small things, pack containers. Label them, share the building's essentials, and move lots at once. If you need full independence, legacy compatibility, or strong separation, move rooms. Include the operating system, the furniture, and all the fixtures inside each VM. So what should you choose? Think about the job. Are you launching a small service that needs to scale up during lunch rushes? Boxes, containers are probably the best. Are you running decades-old software that must see its old wiring? You'll likely want a whole room VM. And sometimes the smartest move is a mix. Boxes for most of the apartment and a few rooms carried intact. At the end of the day, whether you pack boxes or move rooms, the point is to get your apps working reliably in their new home. The container versus VM choice is simply a question of trade-offs: weight, speed, compatibility, and isolation. Now that you've seen the moving day version, you'll spot these decisions in the clouds and data centers around you. If you enjoyed this unpacking, like and subscribe for more friendly cloud stories, and drop a comment about your favorite moving hack.